Hello and welcome to today's daily Leetcode challenge. Today we'll be solving question 92. First, I'll go through my thought process as I come up with the solution. Later, I will compare my solution to the solution of others to see where I can improve my algorithm, etc., etc. With that, let's begin the question. Question 92, reverse linked list 2. Given a head of a singly linked list and two integers left and right, where left is smaller or equal to right, reverse the nodes of the list from position left to position right, and return the reversed list. Okay, in my own words, I'm given a singly linked list, very simple, and I have to reverse some portion of that. Inclusively, the portion is from left to right, where left is smaller than right. So the visual gives it away. I have to reverse a portion of that linked list. Right. And there's a small example. I have the head pointing to a linked list that goes 1, 2, 3, 4, 5. And if left, which points at the second node, and right, which points at the fourth node, are the parameters, then I reverse what is in between inclusively those two bounds. Okay, and then there's another example where linked list is only one element, which, yeah, I guess in that case, we don't actually have to reverse anything. So here's my thinking process. I see that actually this is the second version of this problem. I'm assuming the first version of the problem simply asks to reverse the whole thing, which sounds probably a bit easier because there we don't have to worry about not having to reverse portions of the list. Here we do. The reversing a list link usually happens in one of two ways. Either you actually move the nodes in positions, meaning that you move a node's self.next pointer to another node. In the example where we reverse the whole list, that would mean that 5 is now pointing to 4 rather than the other way around. 4 is pointing to 3, 3 is pointing to 2, 2 is pointing to 1. That is, I would say, the harder way, and you're doing a hard reorder of the list or reverse. There's another approach where we don't have to rewrite next at all. What we simply do is rewrite the values. So nodes stay in place and next pointer never gets overwritten, but the values in those linked lists get moved. And in my opinion, that is a easier implementation because we don't have to worry about where next is going to point to. And there's probably going to be a ton of edge cases in the case where we're reversing only a portion of that list, where maybe next has to now be pointing to another value. Like for example, here I know that I have to remember 1, the first node, and the fifth node, and then I have to know that fifth node's next is going to be pointing to what used to be the end of the sublink list, but now is the front of the sublink list, etc., etc. So what I'm going to do is stick with the second approach where I simply have to rewrite the values in each of the linked list nodes. Rewriting the values will be easier because all I have to do is get 2 pointers to a position to the correct position. There would be the left pointer, which points to a node, and the right pointer, which points to a node. When I get them into the right places at the same time, meaning that the left would be pointing at 2, the right would be pointing at 4, I could call a switch, I could replace your values, the values would be replaced, and the outcome would be exactly what is here, and we don't have to move any nodes actually. And so I'm going to take that approach instead. I believe that it's easier. With that, let's begin the implementation. Okay, so my approach was two pointers, right? A left and a right pointer. So let's call this left node, which points to head, and I'm going to start by putting left node in the correct position. I'm going to put left node in the correct position because that's going to get me ready to, that's going to get one of my nodes into the correct place. I'll worry about the right node later on. I is equal to 1 while I is less than left, less than or equal to. Let's say less than or equal to left. I'm going to say, no, sorry, less than. Because if it's less than, then I'm saying left node equals left node next. And that's it. And I plus equals 1. All of a sudden, print left node value is in the correct place. It's going to be pointing at 2. And now the print, what did I spell print wrong? As usual. Now we have one of them in the correct position. We have to worry about getting the other one into the right place. Standard out at 2. Getting the right one into the correct position would be a little bit harder because not only do we have to get it into the right position, we also have to be able to very easily move from right to left in that direction. Moving from left to right is very easy. You simply call next. But how do you move from right to left? Well, from right to left, you can define a recursive function. Let's call it rec with a node. And in that rec function, I'm going to say that, I want to have a rec function. I also want to point I to it. I want to say that if node, let's see, what is my approach here? I'm diving deep into rec in the case where node.next is, so if node is there, then I'm going to say rec node next and I plus 1. Rec node next, I plus 1. So this way I'm going down deep into the linked list, and as a result of this, after I execute it, I am essentially greeted by the rightmost node. So let's say node val. If I was to simply execute this, I should, let's say rec with a head and 0, I should see a print of 5, 4, 3, 2, 1. Let's see if we get that. 5, 4, 3, 2, 1. Great. So now all that is happening here, let me put this into the scope, non-local left. What's happening here is I all of a sudden have access to my right node as well. Right node is equal to simply node. And now I have my right and my left node. I really don't need this. What I want now to do is I want to I want to figure out when I have to make the switch, right? When I can make the switch. So and the switch that I'm making is dependent on this I. I is my way of knowing which index I'm in. So if I is less than right, then I make this switch. Temp is equal to node val is equal to left node val left node val is equal to temp. And when I make that switch, I also have to say node left. Node equals node next. So what did I do here? I checked if my index, if my right node is in the correct place. I didn't actually, I'm not iterating through my right nodes the same way as I'm iterating through my left nodes. The way I'm iterating through my right nodes is by this recursive function that I keep on exiting out of and happening to be in a previous node. So if I is less than right, and let's see if that's correct, or should it be I is less than or equal to? Well, if I call this with 1, then it would be 1, 2, 3, 4. So it has to be right or equal to. Then I make that switch. Temp equals node val left node dot val temp, and make the switch. Oh, one more thing. I want to stop switching my nodes once I get to the middle. So this has to be I also greater or equal to right plus left divided by 2. Okay, so now that I call this recursive function with the correct I value, I should be able to return my head. So in this case, again, nothing is being switched. The nodes themselves stay where they are. The values get switched. Let's hope that this runs smooth. And there we go. Awesome. Except not awesome. Output 5, 3, left and right. Output 3, 5, expected 5, 3. So I'm guessing that somewhere the condition didn't go through correctly. Okay, so in this scenario, I probably let's just see what the edge case is. My guess is that one of these is wrong. Right is I is smaller or equal to right. And if right is pointing at 2, then the first iteration I'm going to have I is equal to 1, and then I is equal to 2. Next is going to be pointing at null, but node is going to be pointing at a right value. Rec node next. But if I is smaller or equal to 2, which is correct, then I should be able to make the switch. Let me see what I is here. Oh, 3, 5. I should have used up that. I should have used up that test case. Use test case. Let's remove these for now. Let's run this and see where the print statement is happening. Standard out for the 2 and the 1. So we are going into it, but we're doing the replacement twice. We only have to do the replacement once. Let me see if this works. Okay, so my guess is that that was the issue. What was happening is if you replace the same value twice, so for example, if we are replacing 4 and 2, and then 3 and 3, and then the 4 and the 2 again, then we're just back at the same place where we started. And this condition here was including that scenario. Okay, and there we go. So without that, we are good. We're beating 72%. which is good, but not great. Let's see what faster approaches are there. Um, okay, so the approach here is that dummy is equal to list node 1, dummy next equals head, and then pre-cur. I'm getting a sense that in this case, they're actually going with the first approach where you actually move the next pointers rather than the values. And let's see if how they were able to do this. They placed a pre-dummy node and a node that precedes the first node, first head. And so pre and cur are just that. Find the position I in 1 to left. I have to find the position where current is equal to current.next, pre is equal to pre.next. So I find the position where current is pointing to the beginning of the linked list that we have to reverse, and then reverse I in range right to left. Sorry, right minus left. Temp is current.next. This is way better. This is way faster. Okay, so scratch what I was saying in the beginning. I guess what I never really was comfortable with is using this dummy variable to pretend like there's something in front of me, in front of the head. But what they're doing here is they're saying that dummy is going to be this new node that is the first node, the first list node, and then they find the correct position for current and previous. They find the correct position for current and previous by iterating through 1 to left, and then for range right to left, I'm going to say temp is equal to cur.next. Temp is equal to current.next. That's the node. Current.next is equal to temp.next. Current.next is equal to temp.next. Okay, I have to think about this visually. I have two nodes, current and previous. I'm making another node that is actually next. Next temp current.next is equal to temp.next. Super confused. Temp is looking one ahead of current, so that is essentially the next over. We have the current pointing at the center node, previous pointing to the left, temp pointing to the right. I'm saying that current.next is now equal to temp.next, which should say that that is next next. So current.next is equal to next next. Temp next is now equal to pre next, which should be pointing at current, and pre next is equal to temp. Oh boy, I don't know if I can wrap my head around this. I might have to draw this out. However, in the meantime, let's try going through with this one here. The approach there was that we have a dummy node, that has a value of doesn't matter, and the next of head. Now I want to have a previous, which is for now just equal to none, and for thing in range 1 to left, I want to get current is also equal to dummy, and this is head. I want to say cur is equal to cur next, dummy is equal to dummy dot next. And now for in range right minus left, this is what they are doing. Cur. I'm going to draw this out. I'm not just going to submit this right away. So dummy next. So this should work. Oh, pre. They call it pre. Okay. This works. However, I want to have this right here so I can see what is going on. I can maybe write down what is going on. Let me give myself some space. What is temp? If current is pointing at 2, which in this case it actually is, temp is equal to 2. Temp is current dot next. Temp is equal to 3. What is current dot next pointing to? Current dot next. Current dot next has to be pointing to 1 in order for this to be reversed. Current dot next has to be pointing to temp dot next. What? Temp is already pointing to 3, so why would 2 be all of a sudden pointing to 4? Okay. Cur dot next is equal to temp next. Temp is equal to 3, so 4. Temp next which is temp next. What was temp? Temp is 3, and 3 is pointing to 4. Temp dot next is now pointing to pre next. What is pre? Pre has to be equal to 1. Pre dot next is actually 2. Oh my God, why is this? How do I visualize this? Is there a way to reset the test cases? Reset test cases. If I just print these guys out, print current, let's say pre, current, and temp, since temp is actually just next. So pre, val, cur, val, and temp, val. And so I should, out of this, cur is spelled with 1 R. I should, out of this, the initial thing that I should see is 1, 2, 3. And then I should see 1, 2, 4. I'm really confused because I don't understand how are they not reversing? Are they just maybe mm, okay, temp is equal. Okay, I don't know if I'm comfortable with just stumbling around for this long. How would I let me do last attempt. I'm going to just print everything. Cur what did I have? I had this. Five more minutes, and then if you don't if you can't watch this anymore, then I don't blame you. Um, so there's only two switches that are happening, and in the first case, why are they not different? Cur.next is equal because I'm only rewriting the nexts. So I'm rewriting the current next, the temp next, and the pre-next. The current next I'm rewriting to what used to be nxt. I want to call this nxt because I want to call this nxt because it is pointing at 3. So if I am rewriting the current next to be the next next, that means that 2 is all of a sudden now pointing at 3. What if instead of this, I do this? Node equals to uh, dummy next while node print node value node node next. There we go. So now at each iteration I get to see what the linked list turns out to be. And why didn't this work? Because I did not have this in the right place. So after the first iteration, my linked list looks like 1, 3, 2, 4. 1, 3, 2, 4, and then 1, 4, 3, 2. So what actually happened? Did I just... So I'm not switching them. Am I like almost rotating it? Um, my current, I'm not gonna try to understand this. And I don't really, guess I'm running out of time. Um, that is I guess the difficulty with these approaches. They're not, I would not be able to come up with this faster. But however, it is significantly faster. So, um, yeah, I guess go with whichever one is better, and this one doesn't even run faster. So yeah, I'm going to show you this, but please, if you find something, if you understand the previous one and it's more intuitive, then go ahead and use that one. All right, thanks for watching, and I'll see you later. Bye.